Right now, the United States is in the middle of its most ambitious industrial push in more than 50 years. It's a massive effort to completely reshape the global supply chain for what is arguably the most critical product on Earth, the semiconductor. So today, we're going to break down this incredible high-stakes race for chip supremacy.
Okay, so here's our roadmap for this. First, we're going to look at America's absolutely massive $300 billion bet on this industry. Then, we'll zoom in on Intel's incredible high-stakes gamble to get back on top. From there, we'll take a tour of the new mega factories popping up in Ohio and Arizona. And finally, we're going to get down to the nitty-gritty and explore the groundbreaking tech inside the chips themselves.
All right, let's start with the big picture, America's $300 billion chip bet. And this is so much more than just building a few factories. We're talking about a massive strategic realignment that touches everything from national security to the economy.
The scale here is just mind-boggling. We're talking over $300 billion in combined public and private investment. To give you some perspective, that's more than the entire Apollo program cost, even when you adjust for inflation. And what's fueling this boom? It's the Bipartisan Chips and Science Act, which is really a landmark piece of industrial policy.
Now, what's really interesting here is that this isn't just a race for the fastest, most powerful AI chips. It's about rebuilding the entire food chain. So on one hand, yeah, you've got this huge push for those cutting-edge Angstrom-era chips. But on the other hand, and this is just as important, it's about securing the supply of all those legacy and analog chips. You know, the workhorses that are basically the nervous system for our cars, our planes, and our defense systems. So you gotta ask, why all this? And why right now? Well, it's pretty much a perfect storm of factors. Geopolitical anxiety is super high because, let's face it, the supply chain is heavily concentrated in East Asia. The pandemic really hammered home just how vulnerable that makes our economy. So at the end of the day, this is all about securing technological sovereignty and, frankly, inventing the new manufacturing paradigms needed to keep Moore's Law alive. You know, a national strategy like this needs a corporate champion, a company willing to really step up. And right at the heart of this American effort is one company making a historic bet to regain its manufacturing crown: Intel. So let's dig into their 5-node gamble. As part of its big comeback strategy, Intel laid out this absolutely breakneck roadmap: deliver 5 advanced manufacturing processes, they call them nodes, in just 4 years. Think about that. Each node is a huge leap forward in shrinking transistors. The goal here is to leapfrog rivals like TSMC and Samsung and retake the title of the world's most advanced chipmaker.
And calling this plan audacious is probably an understatement. Seriously, experts have labeled it the most aggressive technology roadmap in the history of the entire US industry. It's a high-risk, high-reward gamble, not just for Intel, but for the whole American semiconductor ecosystem.
Okay, now we're gonna zoom in from that high-level strategy to where the silicon actually meets the soil. We'll start with the project that really represents America's long-term future in chips, the brand new Silicon Heartland being built from the ground up in Ohio. Intel is kicking things off with a $28 billion investment to build 2 cutting-edge fabs, but that's just the start. The master plan here is enormous, with room for up to 8 fabs and a potential investment that could top $100 billion over the next decade. We could be looking at what might become the largest chip manufacturing site on the planet. Now here's the really crucial part. This Ohio site isn't for the chips of today. Nope. It's the designated future home of Intel's Angstrom-era chips, where features are measured in angstroms, a unit that's even smaller than a nanometer. They're starting with the 18A and 14A nodes, which means they are literally building the factory for technology that is still on the absolute bleeding edge of development.
So, while Ohio is all about the future, the incredibly high-stakes present is taking shape in the Silicon Desert of Arizona. This is where the rubber really meets the road for Intel's current comeback plan.
In Chandler, Arizona, Intel is spending $32 billion to build 2 enormous new factories, Fab 52 and Fab 62. Together, they form a mega fab complex, and they are the lead vehicles for bringing that critical 18A process into high-volume manufacturing.
And this isn't just a plan, it's happening right now. Fab 52 has already started producing the very first 18A chips. These include the Panther Lake processor for PCs and Clearwater Forest for servers, which uses advanced 3D packaging to stack chip components vertically. This is tangible, real progress on that aggressive roadmap.
But manufacturing the silicon wafer is only half the battle.
So, right next door in New Mexico, Intel has invested another $3.5 billion in an advanced packaging hub. This is where they use their Foveros 3D technology to stack different chiplets vertically. It's a critical step for building these complex, high-performance processors. For our final section, let's zoom in one last time. We've seen the national strategy, we've seen the massive factories. Now let's look at the revolutionary technology that's actually being manufactured inside of them. First up is ribbon FET. This is a fundamental change in how transistors are built. For the first time, the gate material completely surrounds the channel on all four sides, kind of like a ribbon. This gives it maximum control to stop power from leaking, which is absolutely essential as transistors shrink to these microscopic scales. Next is PowerVia. Think of a chip like a city, right? The roads for data signals and the power lines can get really crowded. PowerVia is this amazing breakthrough that moves all the power lines to the back of the chip. It's like creating a dedicated express lane for power, which frees up the front side for faster, cleaner signals.
So these innovations, ribbon FET and PowerVia, are perfected at Intel's research facility in Oregon. Then, using their copy exactly method, the process is replicated down to the finest detail in the new fabs in Arizona and Ohio. This ensures consistency and quality at a massive, massive scale.
And making this next generation of chips possible requires this machine. The high-end EUV lithography tool is one of the most complex and expensive machines ever built by humans. It is pushing the boundaries of physics to print unimaginably small features, and it's an absolute prerequisite for manufacturing the Intel 14A node and beyond.
Today, we are diving into one of the most ambitious, high-stakes manufacturing projects on the entire planet. We're talking about TSMC's massive gamble on building the world's most advanced computer chips right here in the United States.
And the whole story really kicks off with just a staggering number: $65 billion. Now, just to put that into perspective for you, that is the largest foreign direct investment for a brand new project in the history of the United States.
And what was the goal of all that money? Well, it was to take acres and acres of Arizona desert scrub and completely transform it into one of the most technologically advanced manufacturing zones on the face of the Earth.
You know, right from the get-go, a lot of experts were really skeptical. I mean, the costs, the logistics, the cultural challenges, they just seemed immense. And as we're about to see, they were absolutely right to be worried.
Okay, so let's break down the sheer scale of this whole thing. It is truly a story of exponential growth and ambition.
So what started back in 2020 as a pretty significant, $12 billion project, it just exploded. It was fueled by new government incentives and this absolutely voracious demand for AI chips. The commitment just ballooned over $65 billion, with some people talking about a potential roadmap that stretches towards an almost unbelievable $165 billion. This wasn't just building a factory. This was like building a city of technology. And see, TSMC's vision, it wasn't just for one or two buildings. No. They call it a gigafab cluster, which is basically a massive self-contained campus with multiple fabrication plants, R&D centers, even packaging facilities. The idea here is to create an entire ecosystem just for making chips, one that could rival those legendary science parks back in Taiwan. So what exactly were they planning to build with all that money? Well, it wasn't just about quantity. It was about a really strategic climb up a ladder of cutting-edge technology.
This strategy was this brilliant three-step ladder. So step 1, build a foundation with proven 4-nanometer chips. And in this world, remember, the smaller the nanometer, the more powerful and efficient the chip is. Step 2, leap to the cutting-edge 3-nanometer node. But that third fab, that was the real game changer, targeting the future of chip making with next-generation 2-nanometer and A16 process technology. And this makes a really profound statement. This wasn't about the US getting yesterday's hand-me-down tech. By earmarking its revolutionary A16 process for Arizona, TSMC was sending a signal that this site was not a backup facility, but a primary, bleeding-edge hub in its entire global network.
Now, an investment this huge, it just doesn't happen in a vacuum. It required a monumental financial push from the US government to actually make the numbers work. That support started with a massive injection of cash, up to $6.6 billion in direct grants from the US CHIPS Act. Now, this wasn't a blank check. This money was tied to hitting very specific construction and production milestones.
On top of those grants, TSMC also got access to $5 billion in low-interest government loans.
In an industry where a single piece of equipment can cost over $150 million, access to that kind of capital is absolutely critical.
But for a lot of analysts, the real game changer, the thing that made the long-term economics of building in the US actually work, was this massive 25% investment tax credit. For a project spending tens of billions, that single incentive is absolutely key.
So while critics were pointing to the massive uncapped cost to the Treasury, the people who supported it framed it like this. They argued that these subsidies were the necessary cost of securing America's critical technology supply chain for decades to come.
But as construction really started to ramp up, it became clear that the biggest hurdles weren't going to be financial or technical. No, they were going to be deeply, fundamentally human.
And here you have the core conflict. On one side, you have TSMC's intense, almost military-style work culture built on grueling hours and an expectation of absolute dedication. And on the other side, you've got an American workforce that prioritizes things like work-life balance and strict safety rules. It was a collision from day one.
And this friction, it wasn't just talk. It had real consequences. The project's timeline got pushed back. TSMC publicly blamed a shortage of skilled labor, which you can imagine local unions called inaccurate and offensive. Reports from the ground described a chaotic site with complaints about safety violations, disrespect from managers, and even key meetings being held only in Mandarin, which alienated a lot of the American workers.
But this is where the story builds to a truly surprising conclusion. I mean, after all the delays and all the public disputes, the outlook seemed pretty grim.
With so much conflict, the skeptics really felt vindicated. The consensus was there's just no way a US-based fab, with all of these problems, could ever meet the legendary quality and efficiency standards that were set in Taiwan.
But then they finally turned the machines on. And what happened next? Well, it confounded just about everyone.
The results were astonishing. The yield rate, which is basically the percentage of perfect functional chips you get from each silicon wafer, it's the key measure of manufacturing excellence. It wasn't just good. Reports started coming in that it was comparable to, and in some cases, even higher than the yield from TSMC's legendary fabs back in Taiwan. It was just a stunning technical success.
And this success, it was about more than just one factory. It completely debunked the myth that American labor couldn't handle this kind of precision work. And it triggered a huge wave of new investment, creating a true end-to-end made-in-the-USA supply chain, with crucial partners building advanced packaging facilities right there in Arizona.
So you probably wouldn't expect a high-tech war to be brewing in a quiet farm town in Texas, right? But that's exactly what's happening. Samsung is waging this all-out campaign, not with soldiers, but with silicon. And this is so much more than just building a factory. We're talking about building an entire empire to take on the world's most dominant chipmaker. So let's dive into how this absolutely massive Texas-sized bet even happened. So what's the price tag for an ambition like that? Get this, a staggering $40 billion. Yeah, you heard that right. This is one of the largest foreign investments in US history. It's this monumental bet that the future of AI, 5G, all that advanced tech can actually be built right here in America. But you know, this isn't just a story about a big pile of cash. It's a real drama. We're talking about a grand vision that came this close to collapsing, a crisis that seriously threatened the company's future, and then this incredibly high-risk pivot that could literally change the entire landscape of global tech. Okay, so how did this all get started? Let's rewind a bit and look at the original blueprint, a plan that was born from some serious optimism. So back in 2021, the vision was crystal clear. Samsung comes out and announces this massive expansion, and the goal? To go head-to-head with their arch-rival TSMC. The plan was to open this new factory in 2024, just churning out these super powerful 4-nanometer chips, which at the time were some of the most advanced you could get. They wanted to make them for all the biggest tech companies in the world. I mean, it was a bold, really aggressive move. Now, to fuel a vision this big, you need some serious backing. And Samsung got it, securing support from the US government's CHIPS Act. Now, okay, the final grant money was a bit less than they'd hoped for initially, but they still got this massive 25% investment tax credit. And that's absolutely crucial, right? It's a huge incentive from the government for this multi-billion-dollar project to bring chip manufacturing back to American soil. All right, so the pieces are all in place, right? Billions of dollars are committed, the government is on board, the Texas dream is really taking shape. But here's where the story takes a turn. At the exact same time, a crisis was quietly unfolding deep inside Samsung's production lines. And the whole grand vision, it started to crumble. And not because of money, but because of tiny, microscopic defects. And this right here, this shows you the absolute core of the problem. It all comes down to something called yield rate. So what's that? It's basically the percentage of good, usable chips you get from a single silicon wafer. Now, TSMC was just crushing it, hitting an incredible 90% or even higher. But Samsung, they were reportedly stuck, struggling around 50%. In this business, that is catastrophic. It means your costs go way up, everything is uncertain, and you just can't be a reliable supplier for your customers. So, you can guess what happened next. The consequences were swift, and they were brutal. With production so unreliable, major partners started running for the exits. First, Google announced it was moving its Tensor chips for the Pixel 10 over to TSMC. Ouch. Then Qualcomm, a longtime partner, shifted its flagship Snapdragon chips exclusively to TSMC too. And the reason was simple, right? They needed performance and reliability, and Samsung just couldn't deliver. Look, this wasn't just a little setback. This was a full-blown crisis of confidence. The narrative, as this quote shows, became one of existential risk. And what does that mean? The fear was that Samsung's entire business of making chips for other companies could just fail. They'd end up only making chips for their own products, and that model just doesn't work when you've built these multi-billion-dollar factories. These places are designed to serve lots of customers, not just one. So imagine this. You've built this massive facility in Texas for customers who are now literally walking out the door. Samsung was staring into the abyss. So what do? They make a decision that you can only describe as a bet the company leap of faith. They just scrapped the entire original plan. Gone. The 4nm factory was basically dead on arrival. And instead of trying to patch up the present, they decided to just leapfrog straight into the future. The new goal? Retool the entire facility for these hyper-advanced 2nm chips. And to give you some perspective, these chips are way smaller, faster, and more powerful than anything before them. This isn't like a simple software update. This means completely new equipment, totally different processes, the whole shebang. But a pivot this massive comes at a huge cost, and that cost was time. The 2024 opening? Yeah, that wasn't happening anymore. The new target is now 2026. So for 2 whole years, this multi-billion-dollar facility is just gonna sit there, mostly dormant. It's like this massive, silent monument to a high-stakes gamble, just waiting for the technology and the market to finally catch up. But just when things were looking their absolute bleakest, a lifeline appeared. Samsung's incredibly risky bet on the future, well, it found a believer. And it happened to be one of the biggest names in tech. And that lifeline, a $16.5 billion contract with Tesla. The deal is to produce Tesla's next-generation AI chips right there in that Taylor facility. This wasn't just any customer. This was the anchor tenant that Samsung desperately needed. It was the validation for their entire 2nm strategy. So you've got to be asking, how did they pull off such a monumental deal? Well, the secret sauce is what's called the turnkey advantage. See, for AI, you need 2 things packaged tightly together: the processing chips and high bandwidth memory, or HBM. And HBM is absolutely essential for training today's huge AI models. The thing is, Samsung can do it all under one roof. They're a one-stop shop. And that's something their rival TSMC, who doesn't even make memory, just can't fully match. And they're not stopping there. To sweeten the deal and lure more customers back, reports are suggesting that Samsung is offering their 2nm wafers at a staggering 33% discount compared to TSMC. I mean, that is an aggressive, high-risk pricing war. They are fighting to regain market share one customer at a time. But, you know, this comeback story, it isn't just about one factory or one big customer. It's way bigger than that. It's about them trying to replicate an entire industrial ecosystem from South Korea and plant it right in the heart of Texas. They're basically creating what you could call a chipopolis. And trust me, this has huge implications for the global tech supply chain. Yeah, Samsung is bringing its partners along for the ride. I mean, just look at this. You've got dozens of South Korean suppliers setting up shop in Central Texas, companies that provide everything from critical chemicals to the power systems. They're even building a massive industrial park just to house them all. So you see, it's not just a factory anymore. This is the foundation of a new American chipopolis. And it's a really strategic move to de-risk the global supply chain by building all this advanced manufacturing capability right here on US soil. To really get where we're going, we first have to understand the problem. You see, for the last decade, the entire semiconductor industry has been pushing the absolute boundaries of physics, and it looks like they've finally hit a wall. So for about 10 years now, the king of the hill has been a technology called FinFET. I want you to picture a tiny raised channel, they call it a fin, that electricity flows through. The gate, which is basically the on-off switch, wraps around this fin on 3 sides. This design was a total breakthrough. It gave us incredible control and let us shrink chips all the way down to the 3-nanometer scale. But here's the catch. When you shrink that FinFET design down to the scale you need for 2-nanometer chips, well, physics starts working against you. The gate's control just isn't perfect anymore. It can't really stop tiny bits of current from leaking out, even when the switch is supposed to be off. And look, in a chip with billions of these things, those tiny leaks add up to a huge waste of power and a ton of heat. So, if the current champion is hitting its limit, what's next? Well, the industry's answer is a brilliant new architecture, one designed to solve that leakage problem once and for all. And this just perfectly shows the difference. Instead of that vertical fin, Gate-All-Around, or GAA, uses these horizontal nanosheets stacked on top of each other. Now, the crucial part here is that the gate completely surrounds the channel on all 4 sides. It's like going from grabbing something with one hand to wrapping both hands completely around it. The control you get is just absolute. Now, that 4-sided control has some huge implications. It gives engineers way better command over the electricity, and that means they can crank up performance while actually lowering how much power it uses. For the incredibly power-hungry AI applications that are coming, this isn't just a nice-to-have, it is an absolute necessity. It's like being able to shut a tap off completely, slashing all that wasteful leakage power that plagues modern chip. So this huge technological shift, this is the battlefield where our 2 titans, Samsung and TSMC, have decided to fight it out. But here's the thing, they haven't chosen the same weapons. In fact, they've taken 2 completely different paths. At the 3-nanometer generation, this is where their strategies just totally diverged. Samsung took a massive gamble. They decided to be the first mover, jumping into the brand new GAA architecture right away, hoping that all that early experience would give them an edge. TSMC, on the other hand, played it safe. They stuck with the proven, reliable FinFET tech for their 3-nanometer chips. They prioritized stability and high-volume production. And in the short term, TSMC's conservative strategy paid off big time. So what happened? Well, Samsung's gamble kinda backfired. The new GAA process was so complex that they had serious production problems and really low yield rates, which just means they were getting far fewer working chips for every silicon wafer they made. While Samsung was struggling, TSMC's reliable FinFET chips were just capturing the market. In short, Samsung's bold move became a pretty painful lesson. But this race is far from over. Actually, the real showdown is just about to begin. The entire game is now moving to the 2-nanometer level, and at that level, everyone has to use GAA technology. We are at a critical inflection point right now. TSMC is set to debut its own version of GAA in 2025, which basically levels the playing field. So the big question is this: will Samsung's painful early experience with 3nm GAA actually give them a head start now? Or will TSMC's legendary manufacturing power let them master the technology quickly and just keep their lead? And you know, this abstract tech race is being decided in very real places. The physical arenas for this whole contest are these massive new fabrication plants, or fabs, right here in the United States. TSMC is building in Arizona, while Samsung is setting up shop in Taylor, Texas. It's a huge strategic move to secure future supply chains, and it means the winner of the 2-nanometer era could very well be decided right in the American Sunbelt. And just when you think you've reached the absolute cutting edge, guess what? The industry is already looking to the next horizon. This race, it never, ever stops. So the next major hurdle is called backside power delivery. Think of it like a skyscraper. Right now, all the plumbing and electrical wiring runs through the same walls as the offices. Backside power delivery moves all that wiring to a dedicated service layer on the back, freeing up the entire front for more logic connections. It's what allows for even denser, more powerful chips, but it's just another layer of mind-boggling complexity to master.
You know, when you think about the most important computer chip in the world, what comes to mind? Probably something super fast, right? For AI or gaming? Well, what if the real king of chips wasn't the fastest, but the most basic? Texas Instruments is betting over $60 billion that it is by building an entire empire on the simple, essential components that make our world work. It's a huge gamble, so let's break it down.
All right, to really get what TI is doing here, we need to completely shift our thinking. Forget about all the flashy, super glamorous AI processors you hear about in the news. We're going deeper, way deeper, down to the fundamental building blocks of all modern electronics.
What we're talking about are analog chips. Now, these are like the nervous system for all electronics. They handle things like power management, and they translate real-world signals, like temperature or sound, into digital data that a computer can understand. You find these things in literally everything, from your car to factory robots. But here's the really crucial part. These chips have incredibly long product life cycles. We're talking decades sometimes. And that is the key. It means the factories TI is building right now will still be churning out profitable chips for a very, very long time to come.
Okay, so if you're TI, how do you completely dominate a market for these cheap, essential chips? Well, their answer is actually rooted in some simple, almost elegant geometry. And, of course, a massive, massive investment.
For decades, the entire industry was built on these 200mm silicon wafers. It was the standard. But TI is going all in on 300mm wafers. And the math behind this is simple, but it is so powerful. A 300mm wafer has more than double the surface area. Now, this isn't just about being bigger for the sake of being bigger. It's all about efficiency. You can cram way more chips onto one wafer, and you get a lot less waste from the edges. It just creates this enormous built-in advantage.
And here's the magic number. That simple change in diameter lets TI crank out roughly 2.3 times as many chips per wafer compared to its rivals. I mean, that is a huge structural advantage that's just built right into the physics of how they make things.
So what does this all mean? It leads to one very powerful outcome. Once that huge upfront cost of building the factory is paid off, TI can produce every single chip for pennies less than anyone else. And when you're selling billions and billions of these things, those pennies add up. They create what's called an economic moat. It's like a profit fortress that's almost impossible for competitors to get across. Right, so this whole strategy isn't just some theory on a whiteboard at corporate headquarters. Nope, it is taking shape right now in concrete and steel out on the prairies of North Texas. And the scale of it is, well, it's almost hard to believe. The heart of this new empire is in Sherman, Texas. And just look at this timeline. The pace they're moving at is just relentless. They proved the 300mm concept works, then broke ground in 2022. The first factory is going to be up and running by late 2025. And get this, they're so far ahead of schedule that the actual shell for the second factory is already finished. It's incredible. And believe it or not, that's just the beginning. The whole Sherman megasite is designed to eventually house up to 4 of these massive interconnected fabrication plants. It's a really smart modular approach. It lets them scale up production as demand grows without the huge delays you'd normally have starting a new project from scratch. It's honestly hard to wrap your head around just how ambitious this is. The total investment across both Texas and Utah could top $60 billion. I mean, to put that into perspective, that's more than what some countries spend on their entire high-speed rail networks. This isn't just building a factory, it's like a private infrastructure project on a national scale. But this whole monumental effort isn't just happening in Texas. TI has opened up a second and equally strategic front out in the mountains of Utah. So out in Lehi, Utah, TI pulled off a really brilliant move. Instead of building a factory from the ground up, which takes forever, they just bought a fully built 300mm factory from Micron back in 2021. That move alone saved them years. So they retooled that facility for their own analog chips, and then they immediately broke ground on a brand new $11 billion factory right next door. Super smart. You know, what's also really interesting about this expansion is how TI is thinking about one of the biggest challenges in chip manufacturing: water. Especially in a dry state like Utah, this is absolutely critical. So the new factory is being engineered to recycle water at nearly double the rate of the old one. That's a huge deal for long-term sustainability in the region. Of course, this massive private investment isn't happening in a vacuum. The US government, through the CHIPS Act, is providing some serious support to bring this kind of manufacturing back to the US. So TI is getting direct funding, and they expect to claim billions in investment tax credits, which really helps make these enormous projects financially possible. Okay, so you can plan for billions in investment, you can build the world's most advanced factories, but none of it works without the right people. And this, right here, is TI's next great challenge. Yeah, it turns out the biggest hurdle in this whole $60 billion plan isn't silicon, it's not steel. The real limiting factor, the real bottleneck, is people.
It's finding and training the highly specialized workforce you need to actually run these incredibly advanced facilities. I mean, the numbers here are just staggering. The Sherman site alone is going to create around 3,000 new high-tech jobs. And we're talking about everyone from PhD-level engineers to the skilled technicians who maintain all the complex robotic systems. These are not jobs you can just fill with a simple ad in the paper.
So what's TI's solution? Well, they're basically building their own workforce from the ground up. They're creating a talent pipeline that starts all the way down in local schools, investing millions to get kids interested in STEM subjects early on. And from there, they're partnering directly with community colleges to create custom certification programs that will feed skilled technicians right into their new factories. It's a long-term play.
So when you step back and look at the whole picture, this entire $60 billion strategy really boils down to one powerful idea. While everyone else is chasing the next, fastest, bleeding-edge digital chip, Texas Instruments is making a calculated, absolutely massive bet on owning the foundational, indispensable components that everything else is built on top of.
So, enter GlobalFoundries. See, a lot of the big tech companies they design chips, but they don't actually make them. They hire a foundry to do it. You can almost think of GlobalFoundries as a mercenary army for the industry, building chips for just about everyone, from car companies to defense contractors. And they very cleverly position themselves as the go-to, trusted foundry for the Western world.
And being that trusted player, well, it's attracting some serious cash. Thanks to the CHIPS Act, the Commerce Department just awarded GlobalFoundries a staggering $1.5 billion. That's a huge investment to expand their work right here in the United States. But wait, there's more. The money doesn't stop there. New York State is also jumping in with its Green Chips program, adding another $575 million in tax credits. And this tells you something really important. It's not just about making chips in America. It's about making them sustainably, with real goals tied to using renewable energy and cutting emissions.
Okay, so where is all this money actually going? Well, the first big piece of the puzzle is GlobalFoundries' giant Fab 8 campus up in Malta, New York. And this isn't just about making the factory a little bigger. No, this is a really smart, three-pronged plan to strengthen the entire US tech supply chain.
So here's the plan. First, they're beefing up their ability to make chips for cars, locking in deals with companies like GM. Second, they're building a whole new fab specifically for chips needed for defense and for edge AI. The AI that runs on your smart camera, not in some massive data center. And third, and this is a huge deal, they're finally bringing chip packaging back to the US.
For years, packaging has been this giant glaring hole. I mean, think about it. You could manufacture the most advanced, most sophisticated chip in the world right here in the US, but then you had to send it halfway across the planet just to get it put in its final little plastic case.
This slide just shows you how absurd the old way was. A chip is made in the US, then it spends weeks on a container ship to Asia, gets packaged, and then spends weeks on a ship coming all the way back. It was slow, it was inefficient, and frankly, it created some massive security risks. So by bringing packaging onshore, GlobalFoundries is creating a secure end-to-end process for America's most important tech. Now, while the New York campus is focused on scaling up the technology we rely on today, the second front of this strategy is all about the future. And that's happening in Essex Junction, Vermont. If New York is securing the present with silicon, Vermont is trying to win the future with a revolution in new materials. And get this facility is almost 70 years old. In the tech world, that's practically ancient. It should be a museum, but instead it's being completely reborn. It's set to become the #1 place in the US for manufacturing a material that could completely change electronics as we know them. And that material is called gallium nitride, or GaN. Here's the easiest way to think about it. If silicon is like a garden hose, GaN is a high-pressure fire hose. It can handle way more power in a much smaller package. It's the reason your new laptop charger is so tiny, and it's absolutely critical for things like efficient EV chargers and powerful 5G cell towers. Yeah, this comparison really says it all. Mastering how to make GaN isn't just a small step up. It is a massive strategic leap. It means the US could lead the way in the power electronics that are going to drive everything from green energy to the next generation of communications.
So, we have scale and integration in New York, and we have next-gen materials being developed in Vermont. But what ties all this together? There's one core purpose that turns this from just an economic plan into a national security mission: the Trusted Foundry Shield.
Now, Trusted Foundry is not just some fancy marketing slogan. It's an official accreditation from the US government. It means a facility meets these incredibly high security standards for literally everything: its employees, its physical security, and the integrity of its entire supply chain.
And the stakes here, well, they could not be higher. This quote from the source is honestly chilling. The Department of Defense has worried for years about a chip being compromised with a hidden backdoor. A single malicious piece of code could make our most advanced military equipment totally useless at the worst possible moment.
And that is what being a trusted foundry is all about. Through partnerships with companies like Lockheed Martin, GlobalFoundries is basically creating a secure bubble, a domestic enclave, to build the chips that go into missile guidance systems, Navy radar arrays, and the communications gear for our special forces.
So let's just step back and look at the big picture for a second. This whole investment, this whole strategy, it's about so much more than one company. It's a coordinated two-front approach to make sure the US can make the chips it needs, whenever it needs them, without having to depend on anyone else.
When you lay it out like this, the strategy is brilliantly simple. You've got Malta, New York, focusing on scale and integration, securing the supply chains we need today for cars and defense. And at the same time, you've got Essex Junction, Vermont, focusing on pure innovation, mastering the materials that will let America lead the technologies of tomorrow.
I mean, it sounds completely backward, doesn't it? While the rest of the industry is in a mad dash for the next tiny nanometer, Analog Devices is pouring a fortune into a facility that was built back in 1978. And the wild thing is, it might just be one of the most forward-thinking moves in the entire industry today. Let's get into why. What exactly triggered this billion-dollar bet? Well, the answer really goes back to the pandemic. All of a sudden, global supply chains just snapped. And that exposed a huge vulnerability for everyone. It forced companies like Analog Devices, or ADI, to completely rethink their strategy and figure out how to secure their manufacturing right here on US soil. Okay, so what kind of tech is actually worth this kind of massive investment? They actually call it the Goldilocks node. We're talking about 180 nanometer chips. Now, for your smartphone, that technology is basically ancient. But for the industrial world, it's just right. It's the unsung workhorse chip that's tough enough to survive in the absolute harshest conditions you can imagine. Here's a good way to think about it. Your phone's chip is like a sprinter. It's built for pure speed and power efficiency. These chips, on the other hand, they're marathon runners. They are built for absolute bulletproof reliability. Their larger size means they can handle really high voltages and extreme temperatures, which makes them absolutely essential in factories, hospitals, and power grids. This is how you protect our most critical industries from future global supply shocks. All right, let's zoom in on where this is actually happening. We're heading to the Pacific Northwest, to an area that's historically been known as the Silicon Forest. This is where the physical transformation is creating a new regional powerhouse. The headline number alone is just staggering, over $1 billion. And we're not talking about a fresh coat of paint here. This is a complete gut renovation. They are transforming this vintage asset in Beaverton, Oregon, into a totally state-of-the-art, world-class production hub. So what does that kind of money buy you? Well, for starters, a massive expansion. 118,000 square feet of new clean room space. And that's that hyper-sterile, completely dust-free environment. We're talking cleaner than an operating room, where these microscopic marvels are actually born. And the investment doesn't just stop in Oregon. Right across the Columbia River, ADI is also boosting capacity by a whopping 70% at its facility in Camas, Washington. When you put them together, you're creating this really powerful and connected regional cluster for making semiconductors. This is where the strategy gets really clever. It's called brownfield modernization, which is basically a fancy way of saying you upgrade what you already have. It's so much faster and more efficient than building a brand new factory from the ground up that it's actually attracted targeted funding from the US CHIPS Act, all to get this vital production online as quickly as possible. But, you can have the most advanced factories in the world, and they're really just empty buildings without the right people to run them. And this brings us to the crucial point: how ADI is solving what might be the biggest challenge of all. Because what ADI figured out, and this is key, was that the real bottleneck wasn't going to be a shortage of silicon. It was going to be a shortage of people, those highly trained technicians you need to operate and maintain all this incredibly specialized equipment. So what did they do? Their solution is just awesome. They built their own internal university. It's called SAMU, the Semiconductor Advanced Manufacturing University. In just 8 weeks, this program takes people from all kinds of different backgrounds, like military veterans, and turns them into skilled technicians. The curriculum is hyper-focused on the exact equipment ADI uses, so they are literally creating a perfectly tailored workforce from the ground up. Okay, so we have these modernized factories, and we have the skilled people to run them. But this isn't just a local story out in the Pacific Northwest, it's actually part of a much bigger coast-to-coast vision. And this, right here, is the final piece of the puzzle. By linking its upgraded West Coast hub with its facility all the way over in Shumford, Massachusetts, ADI isn't just building a couple of factories. It's building a coast-to-coast, truly resilient national network, making sure we have a secure domestic supply of these absolutely critical chips. We're going to talk about friction. It's what happens when a huge, long-term government plan to rebuild an entire American industry collides with the messy, volatile reality of the global market. And it's a story that really boils down to one company and one very big number. Okay, let's just start with the number itself, $162 million. This was a federal grant, right? Part of the CHIPS Act, that massive government initiative to bring critical semiconductor manufacturing back to the US. So, this wasn't just a check. This was a symbol of a massive national comeback. And that, of course, brings us to the million-dollar question. Or, I guess, the $162 million question, right? Why on earth would a company on the verge of this massive taxpayer-funded expansion suddenly just slam on the brakes? To figure that out, we gotta look at the bigger picture. So to really get what's going on, you have to remember the mood back then. The mission to bring chip manufacturing back to the US, it was fueled by this incredible optimism. The whole point of the CHIPS Act was to secure our supply chains and create all these great high-tech jobs. Seriously, the mood was electric, and companies were lining up for a piece of the action. All right, so let's meet our main character in this whole saga, a company called Microchip Technology. And look, this isn't some small-time operation. These guys are a huge deal. They make microcontrollers. Basically, think of them as these tiny, specialized little brains that run everything from your car and your washing machine to, and this is critical, some of our most advanced military hardware. So you fast forward to early 2024, and Microchip, they were looking like the absolute poster child for the CHIPS Act. The Commerce Department even announced a preliminary deal for that huge $162 million grant. You can just imagine it, right? The press releases were probably all drafted up. Everything was looking perfect. And we're not talking about some vague promise here. No, Microchip had a very specific, super ambitious plan to beef up its American operations, and they were going to do it on two fronts. Okay, so here's how the plan broke down. $90 million was going to something called Project Hydrogen in Colorado, which was all about modernizing a facility for those really critical military and aerospace chips. The other $72 million, that was headed to Gresham, Oregon, to triple the output of chips for pretty much everything else. It was this really smart strategy, right? Bolster national security and make sure you can still get a new washing machine, both sides of the coin. But then the market did what the market always does. It changed. And you gotta understand, in the semiconductor world, change isn't this gentle little thing. No, it's a violent, whiplash-inducing swing from one extreme to the complete opposite. I mean, look at this timeline. The industry went through a total whiplash. Remember 2021? It was all about shortages, panic buying, companies double ordering just to get their hands on anything, and then bam, 2024 hits, the market cools down, and suddenly all those customers are sitting on huge piles of chips they don't need. Just like that, the market flips from a desperate shortage to a massive glut. And for Microchip, this wasn't some abstract economic trend. The impact was direct, and man, it was painful. Their revenue started falling because nobody was buying. Their own warehouses started filling up with unsold inventory. So what do you do when you're in that spot? You do what any business would have to do. You make the tough call. It was time to slash costs, and fast. And this right here, this is the moment. This is where the messy, short-term reality of running a business just smashes head-on into the government's grand long-term plan. And the result? A totally stunning reversal. Okay, so here's the really crucial detail you have to get. These CHIPS Act grants, they're not just blank checks. The money is tied to hitting specific milestones, mostly spending money on new buildings and equipment. But Microchip's problem was that it needed to stop spending money. If you stop building, you can't get the grant money. They were stuck. It was a classic catch-22. So what happened next? Well, it led to this absolutely jaw-dropping announcement from their CEO. He came out and said, point blank, "We will abruptly stop pursuing the $162 million grant and put negotiations with the government on hold for now." For anyone on the outside looking in, this must have seemed like it came completely out of left field. And the fallout from that decision? It was immediate. That big expansion in Gresham, Oregon, it created exactly 0 new jobs in the first half of 2024. In fact, they had to furlough the workers they already had. And to cut costs even more, they just shut down a factory in Tempe, Arizona, completely. So what are we supposed to take away from all this? What's the broader lesson here? I mean, what does this one company's story really tell us about the massive challenge of trying to steer a national strategy in an economy that just moves at lightning speed? First things first, and this is super important, the company is adamant that this is just a pause. It's not a cancellation. They're saying they still fully intend to do the expansion once the market gets back on its feet. The basic need for these American-made chips, that hasn't gone anywhere. The only thing that's changed is the timing. And really, this gets us to the absolute heart of the whole issue. You see, government plans, they operate on a 5-year, 10-year timeline. They're slow, they're steady, they're static. But a business? A business lives and dies quarter by quarter. It's dynamic, it's constantly changing. And that friction we talked about, it happens right in that messy space where those two completely different clocks, those two different sets of gears just grind against each other. But wait, the story doesn't actually end there with a screeching halt. Because while all the big money construction stuff is on ice, there's another kind of investment that's quietly humming along in the background. And that's the investment in people. And this, to me, is the really hopeful part of this whole thing. See, Microchip is still working with Mount Hood Community College to train the next generation of technicians. A program called Elevate Careers just graduated its first class. They're even working with local high schools to get kids from underrepresented backgrounds into the tech pipeline. So yeah, the big spending on buildings is paused, but the investment in building up the human talent, that's still full steam ahead.
All right, today we're going to talk about one of the most incredible corporate stories I've seen in a long time. Seriously, it is a story about ambition, a near-death experience, and a massive, multi-billion-dollar bet on a single piece of technology that could completely change our electric future. This is the story of a company called Wolfspeed.
So let's just get right to the heart of it. The paradox that makes this whole thing so fascinating. How in the world does a company file for Chapter 11 bankruptcy and then, just 91 days later, walk out stronger than ever with a clear path to dominating a global market? It just sounds impossible, right? Well, to understand how Wolfspeed pulled this off, we have to go back to the basic physics that made them bet the entire company in the first place.
You know, for the last 50 years, one element has basically ruled the entire world of electronics: silicon. But as we're all shifting to a world filled with electric cars and huge data centers, the old king, well, it's starting to show its age. It's hitting its limits.
Okay, so let's break down the matchup here. In one corner, you've got silicon. It's cheap, it's abundant, and we know how to work with it. But if you try to push too much power through it, like you need to in an electric car, it just can't handle it. It leaks energy as wasted heat. But in the other corner, you have the challenger, silicon carbide. It is just better. It's more efficient, it can handle way more voltage, and it can run hotter without even breaking a sweat. For the high-power world we're building, it is the future.
So what exactly is silicon carbide? Think of it this way. It's a special compound material that basically rewrites the rules for power electronics. Its physical structure lets it handle voltages and temperatures that would literally fry a traditional silicon chip. And what that means is you can build electronics that are smaller, lighter, and this is the key part, waste a whole lot less energy.
And this number, this is why this technology is worth billions. Just put yourself in the shoes of a car company for a second. You could add up to 10% more range to your electric car without adding a single ounce to the heavy, expensive battery. I mean, in the super competitive EV market, that is an absolute game changer.
So Wolfspeed saw this coming. They weren't just dipping a toe in the water. They were pioneers, and they decided to do something crazy. They bet the entire company on owning the silicon carbide future. This is a technology that's critical for everything from our cars to our national power grid.
And just look at the scale of this bet. We're talking about $5 billion. A $5 billion investment to build two of the most advanced factories on the entire planet. This wasn't just some small upgrade. This was them trying to leapfrog the entire industry in one go. And the goal behind that $5 billion price tag? It was completely audacious. They wanted to increase their ability to make this stuff by a factor of 10. It was a true go big or go home strategy. No middle ground.
Okay, so their plan was this huge two-part operation. You can think of it as a mine and a forge. First, the giant new factory in Siler City, North Carolina, that was the mine. Its job was to grow these enormous silicon carbide crystals at mind-bogglingly high temperatures. Then, those crystals would get sliced into special 200mm wafers and shipped up to the forge in Marcy, New York, to be turned into the final chips.
I mean, on paper, it's a beautiful, perfectly integrated plan. But there was just one problem. Trying to build two revolutionary, first-of-their-kind factories at the exact same time is unbelievably hard. And this is the part of the story where that grand vision slammed right into brutal, on-the-ground reality. And this quote just nails the crisis they were in. The forge in New York, this incredible, state-of-the-art, fully automated factory, it was finished, it was ready to go. But the mine down in North Carolina, the only place that could make the special 200mm wafers it needed, it was way behind schedule. They had built themselves a brand new Ferrari, but they had absolutely no fuel to put in the tank. And a factory of that size doesn't just sit there quietly, it hemorrhages cash. It was running at just a tiny fraction of its capacity, and that idle time was costing the company a fortune. In just a single 3-month period, it burnt through $47 million. It became this massive anchor, just dragging the entire company straight to the bottom. You know, it's funny how these things happen. It's never just one problem. It was a perfect storm. The construction delays were dragging on right at the same moment the global EV market started to cool off, which slowed down their revenue. On top of that, interest rates were going up, making their huge debt even more expensive, all while they were still spending enormous amounts of cash to build the factories. They were completely caught in a cash crunch.
So with the walls closing in, Wolfspeed had to do something drastic. They filed for Chapter 11 bankruptcy. But, and this is the key part, this was not the end of the story. It was a strategic, surgical, lightning-fast reset.
Honestly, the most incredible part of this whole thing was the speed. This was what's called a prepackaged bankruptcy. It means they had already worked out a deal with all their creditors before they even filed the paperwork. So a process that can sometimes take years was turned into a surgical strike. They were in and out of Chapter 11 in just 91 days. Unbelievable. And the whole point of going through all that pain was to fix their finances. This chart just shows you the incredible result. They wiped out $4.6 billion of debt. They reduced their total debt by about 70%. Now don't get me wrong, this was incredibly painful for the existing shareholders, but it was the move that saved the company, saved the factories, and saved their entire mission. As part of this whole reset, they had to make a really tough call. They decided to permanently shut down their older factory in Durham, the one that made the smaller 150mm wafers. The very facility that basically started the entire industry was now seen as inefficient. It was a powerful signal. The future was 200mm, and there was absolutely no turning back. So, that brings up a huge question. How did a company that was literally on the brink of collapse not only survive, but actually get the money it needed to finish its multi-billion-dollar project? The answer is pretty simple. Wolfspeed. And the technology it was building for making semiconductors here in America was considered too critical to the country's supply chain security to be allowed to fail. What happened next was this massive public-private partnership came together. You had huge incentive packages from state governments in North Carolina and New York. You had new private investors who now saw a much safer bet. And then there was the centerpiece. Up to $750 million in direct grants from the US government's CHIPS and Science Act. Basically, the government decided to co-sign the mortgage on Wolfspeed's future. And then came the final lifeline. In December of 2025, Wolfspeed got a massive tax refund from the IRS, almost $700 million. And this wasn't alone, this was pure cash in the bank, all made possible by the CHIPS Act. When you combine that with their newly cleaned up balance sheet, it gave them the war chest they finally needed to finish the job.
So when a chip company needs to expand, they basically face this huge choice. Do you go the greenfield route? Find an empty plot of land, spend billions, and I mean billions of dollars, and wait 5+ years to build a shiny new factory from scratch? Or do you take the brownfield approach? Find an older, existing factory and just upgrade it for what you need. It's that classic build versus buy decision, right? But in this world, there are billions of dollars on the line. And this is where our story really starts. There's this company, onsemi, based out of Arizona, and they decided to bet their entire future on that second, less glamorous path. Under their CEO, Hassan El-Khoury, they made a really critical decision. They weren't going to try to outbuild their competition, they were going to outthink them. And that thinking, it all came together into this core company strategy, a whole philosophy they call FabRight. So what in the world is FabRight? Well, at its core, it's a strategy to be deliberately asset-light. Instead of just pouring mountains of cash into new buildings, you become, well, kind of a strategic scavenger. You're out there hunting for diamonds in the rough. These undervalued factories you can snap up and transform for just a fraction of the cost and, crucially, a fraction of the time. This whole mindset is perfectly captured in their mantra, don't build what you can buy and don't own what you can't optimize. I mean, think about that. It's incredibly disciplined. Why would you build something if you can just buy a great asset for cheaper? And if you do own it, you better be wringing every last drop of efficiency out of that thing. It's lean, it's strategic, and as we're about to see, it is ridiculously effective. Okay, so to really see this philosophy in action, we need to look at the absolute centerpiece of their US strategy, this massive facility up in East Fishkill, New York. Now, this isn't just some random old factory. In the chip industry, this site is basically hallowed ground. It was originally built by IBM as a totally cutting-edge fab. Later, it passed to GlobalFoundries. So when onsemi swooped in and acquired it in 2023, they weren't just buying a building, they were buying decades of history. And maybe most importantly, a highly experienced workforce that already knew what they were doing. And you won't believe what they got it for. $430 million. Look, for a factory of this scale, one that can handle those big 300mm silicon wafers that are so key to making chips cheaply, that price is an absolute steal. It would cost billions, with a B, to build something even close to that from the ground up. But, you know, buying it was just the first step. The real challenge, the massive engineering puzzle, was that this factory was built for one specific thing, logic chips, you know, like the brains of a computer. But onsemi needed it for something totally different, power transistors and image sensors, mainly for the car industry. This wasn't just swapping out a few machines. It was a fundamental transformation of the factory's entire purpose and its people. And this is where you see a huge benefit of this whole brownfield strategy. See, the previous owner was moving production, which could have easily meant over 1,000 high-tech jobs just gone from the Hudson Valley. So onsemi's acquisition didn't just save a factory, it saved a critical hub of American manufacturing talent. And the results? They were just staggering. By 2025, this transformed factory was an absolute powerhouse. In a single quarter, just 3 months, it shipped over 5 million units. Now, the secret sauce here? They were running their advanced technology on those big 300mm wafers. That gave them this massive cost advantage that their competitors, who were stuck using smaller, older wafers, simply couldn't touch. But here's the thing. This wasn't just some clever one-off deal they pulled off in the US. Nope. This was all part of a much bigger, much more resilient global strategy. So at the same time they were upgrading the New York fab, onsemi was also pouring a massive $2 billion into the Czech Republic. They're building a brand new state-of-the-art facility over there for something called silicon carbide chips, which are absolutely essential for electric vehicles. And the logic behind these two huge investments is just brilliant. It's what they call a local-for-local strategy, and it's basically a hedge against all the chaos in the world. Now they can build chips for US automakers in the US, and they can build chips for European giants like VW and BMW in Europe. This completely de-risks their supply chain from shipping nightmares and lets them tap into government incentives like the CHIPS Acts on both continents. It's a win-win. All right, so this FabRight strategy gave onsemi all this manufacturing muscle. Now, let's see how they use that strength to pivot and attack a brand new, incredibly power-hungry market, artificial intelligence. You see, the explosion of AI created this massive new problem. AI data centers are basically energy vampires. They're like these giant heaters that consume terrifying amounts of electricity. So making the power delivery inside these things as efficient as possible suddenly became one of the most critical challenges for the entire tech industry. onsemi saw this coming from a mile away and they went on a shopping spree. But this time, they weren't buying factories, they were buying key pieces of technology. They acquired specialized businesses to handle everything from circuit protection to the tiny controllers that feed power directly to the hungry AI chips. They basically assembled what they call the complete power tree. And the best part? They now had the manufacturing might in places like East Fishkill to build it all at a massive scale. But this relentless drive for efficiency, this whole philosophy of only owning what you can optimize, it has a difficult and very human cost. And this is the stark reality of that cost. Even as the company was being celebrated for saving over 1,000 jobs in New York, a global restructuring meant they were also cutting roughly 2,400 jobs in other places. It's such a painful dichotomy, isn't it? Huge growth in one area and painful contraction in another. Now, the business logic here is cold, but it's clear, and it ties directly back to that Fab-Right philosophy. The cuts were all about getting rid of older products and shutting down the inefficient factories that just couldn't keep up anymore. The end goal is to have a smaller, but much more highly skilled and more productive workforce that's focused squarely on the future. You know, when you hear the term industrial policy, your eyes might just glaze over. It sounds like something out of a dusty old textbook, right? But what if I told you that you could understand the whole concept just by looking at the story of one single company in Minnesota? Yeah, Polar Semiconductor's journey is, and I'm not exaggerating, a masterclass in how government action can completely reshape an industry. This isn't some dry theory. It's a real-life, high-stakes corporate drama with huge national security implication. So, to get the picture, you gotta know the players in the US semiconductor scene. You've got these big personalities, right? You've got Wolfspeed, kind of the bold pioneer taking all the risks. Then there's onsemi, the established giant. And then, quietly doing its thing in Bloomington, Minnesota, you have Polar Semiconductor. See, they're not trying to be the biggest or the flashiest. Their secret sauce, their genius, is in something way more fundamental, their business model. So, what is this different model? Well, Polar is what's known as a merchant foundry. Now, unlike a company like Wolfspeed, which designs and builds its own chips, a merchant foundry is basically a manufacturer for hire. You can think of them like a super specialized high-tech factory. Other companies bring them the blueprints, the designs, and Polar has all the tools and the know-how to actually build the chips. And you've got to remember this distinction because it is absolutely crucial for everything that happens next. Okay, so for years, Polar was just chugging along, operating successfully, but pretty quietly up in Minnesota. But then, Washington passed a single piece of legislation that would basically launch this company right into the center of a huge national strategy. I'm talking about the CHIPS Act. And this wasn't just another funding bill. Oh no. It was designed to be a catalyst, a trigger for change, and Polar was about to get caught right in the middle of it. You have to look at this from the US government's point of view. Here was the core problem they saw. Polar makes these incredibly important chips, high-voltage sensors, power chips. This is the stuff that literally runs our power grid, our defense systems, our entire aerospace industry. And the American company making them was majority owned by a Japanese firm. Now, that set off all sorts of alarm bells. It was a potential vulnerability that policymakers were absolutely determined to fix. And the CHIPS Act, well, it was practically tailor-made for this exact situation. The goals were crystal clear. First, lock down the supply chain for these critical sectors. Second, make sure that production is under domestic control. And third, if you have to, use federal money to repatriate or, bring corporate control of that technology right back here to the United States. And this is where it all just clicks into place. The story of Polar really became, as one analysis put it, a masterclass in how federal policy can fundamentally alter corporate structure to serve national security interests. Think about that. This wasn't some broad economic stimulus. This was policy acting like a surgical tool, aimed with precision at a very specific target. So the government identified the problem, and they created the tool to fix it. But there was a catch. That tool came with a huge condition, and that one condition set the stage for a really high-stakes deal to bring this critical facility back under American ownership. So here's how this re-domestication, as they call it, actually went down. It was a pretty simple sequence of events, really. First, the condition. If Polar wanted a single penny of CHIPS Act funding, it had to become a US-controlled company. Simple as that. Well, that created an opportunity, and a couple of US firms stepped right in. They put together a deal, a $175 million investment to buy out the majority stake. And the result? Boom. Just like that, control of this critical factory officially flipped back to the US. What's just stunning is how fast this all happened. I mean, we're not talking about a slow, bureaucratic process. The buyout deal was struck in early 2024. By September, the federal funding was all locked in, and before the year was even over, they pulled the trigger on a massive expansion. It was just this rapid-fire cause-and-effect transformation, and it was all driven by that one piece of policy. Okay, so ownership is saddled, the federal money is secured. The mission totally shifted. Now it was time to turn all those dollars and all those policy goals into, well, into concrete and steel. It was time to build a modern fortress of manufacturing right there in Minnesota. Let's talk about the money involved, because the numbers are big. First, you've got a direct commitment from the federal government, $123 million straight from the CHIPS Act. And get this was the very first award finalized for a commercial manufacturer under the entire program. That alone tells you how strategically important this whole thing was. But it wasn't just the feds. The state of Minnesota also stepped up to the plate, kicking in another $75 million. It was a clear signal of local commitment, of them saying, yes, we want to anchor this critical technology right here in our state for the next generation. So you add in the private money with the public funds, and the grand total comes to a staggering $525 million. And we're not talking about a minor upgrade here. This is a complete overhaul and expansion of a facility that's been part of Minnesota's tech scene since way back in the 1960s. So what exactly does $500 million buy you? Well, the main goal is just a massive leap in output. We're talking about doubling production capacity, going from about 20,000 semiconductor wafers a month to nearly 40,000. That's a huge boost to our domestic supply. But this investment is about so much more than just volume. It's about capability. It's funding new automation systems, AI-driven manufacturing tools. It's giving them the ability to produce more complex, more powerful chips, and to do it more efficiently. And, critically, it's also creating 160 high-quality, high-tech jobs for the local community. Now, let's be real for a second. Even with all this investment, Polar can't compete on sheer size with global giants like TSMC. It's just not possible. So their strategy can't be to be the biggest, it has to be the smartest. And their future? It really depends on being specialized and on forging the right strategic alliances. And this is where their strategy gets really, really clever. They're basically leveraging global expertise to boost their local production. They've teamed up with UMC, a massive foundry from Taiwan, who now funnels its global customers that need that Made in USA stamp of approval straight to Polar's factory. And they've also licensed critical technology from Israel's Tower Semiconductor, tech that is highly valued by the defense industry. Yeah, that partnership with Tower, that one is especially important. By licensing this specific, mature, and super reliable technology, Polar can now manufacture these critical chips right here at home. This one move pretty much cements its role as a trusted supplier for the US military. And that, well, that brings the whole national security argument full circle, right back to where we started. First things first, you gotta see this chart. Back in 1990, the US made 37% of the world's semiconductors. Pretty good, right? Well, by 2022, that number had plummeted to just 12%. And look, that's way more than just a number on a chart. It's a massive strategic problem that's been building for decades. And here's exactly why that's so dangerous. Our modern defense is built on electronics, and when you're not making them yourself, when the manufacturing is overseas, you totally lose control. The risk of an adversary slipping in malicious Trojan horses or even kill switches into your gear. That's not a movie plot, it's a constant, real threat. And your supply chains, they could be cut off in a heartbeat. Okay, so let's dig into this a little deeper and really unpack why America's fading dominance in this specific area is so incredibly critical. Now, what's really fascinating here is the timeline. The commercial world, it moves at lightning speed. Your smartphone feels ancient after maybe 3 years. But an F-35 fighter jet, that thing is designed to be flying until 2070. I mean, think about that. An aircraft carrier serves for 50 years. You're talking about two completely different worlds with totally different needs. And this quote, it just nails the core issue, right? The military doesn't always need the tiniest, fastest new chip. Actually, for really harsh environments, think high power, high radiation, older, bigger chips are often physically tougher. Their larger parts can handle extreme temperatures better, and they're less vulnerable to cosmic radiation, which is a huge deal for satellites and jets. The real challenge is making sure you have a guaranteed supply of these mature chips for decades. But, in the face of this huge national problem, there's this incredible underdog story playing out right in the forests of Oregon. It's the story of a small company taking on a giant challenge. This is Rogue Valley Microdevices, or RVM. And man, their journey has been anything but easy. They started out in 2003 by literally scavenging used equipment. Then the 2008 financial crisis hit and nearly wiped them out, forcing them to lay everyone off and start over. But they survived. And their commitment? It was absolute. This wasn't some flashy Silicon Valley startup with tons of venture capital money. To get their first $180,000, the founders, Jessica Gomez and Patrick Hayata, sold their home. They maxed out their credit cards and just put everything they had on the line. And all that resilience, all that sacrifice, well, it paid off big time. Today, RVM, led by co-founder Jessica Gomez, has the amazing distinction of being the first woman-owned and minority-owned business to get funding from the huge CHIPS Act. I mean, what a truly historic milestone. So what is it they actually make that's so important? Well, they don't make the processors you'd find in a laptop. They make something else entirely. They make the chips that move. Okay, so it really comes down to this. Logic chips, they're the brains of a device. They process information. They think. RVM specializes in something called MEMS. That's micro-electromechanical systems. And these chips have tiny moving parts. We're talking gears, mirrors, vibrating beams that let them interact with the physical world. They aren't the brains, they're the senses. They feel and they act. And these senses are absolutely vital for modern defense. I mean, life or death vital. Think about it. If an enemy jams your GPS signal, MEMS, gyroscopes, and accelerometers can take over, letting a missile find its way all on its own. They can be used as tiny biosensors to sniff out chemical agents, or as little mirrors that steer lasers in advanced weapons. It's incredible stuff. This unique capability, well, it brings us right to the present day, and the government's transformative bet on this small Oregon company. So in July 2024, RVM was awarded up to $6.7 million in CHIPS Act funding. Now, you might be thinking, compared to the billions going to giants like Intel, that sounds kind of small, right? But for a company with about $10 million in annual revenue, this investment is a total game changer. It's a massive, massive vote of confidence. So what are they going to do with it? They're making a huge technological leap. See, most MEMS are made on smaller 200mm wafers. RVM is moving up to the big leagues, 300mm wafers. And why does that matter? Because it's the same size used for advanced processors. This means they can basically integrate their MEMS sensors directly onto the same piece of silicon as the brain chip itself. What you get is a smart sensor with virtually zero delay. That is a massive competitive edge. And all of this, the decline, the underdog story, this super specialized tech, it all brings us right back to our central idea, forging the sustained edge. The commercial world is obsessed with the leading edge, the newest, the fastest, the smallest chip. But for national security, what you really need is the sustained edge, a guaranteed, trusted, domestic supply of those robust, mature chips that keep military hardware that's decades old functioning perfectly. And that's really the key takeaway here. The CHIPS Act isn't just about competing for the next iPhone processor. It's about rebuilding a critical industrial foundation. It's about making sure that small, innovative companies like RVM can provide the specialized, reliable components that our defense depends on for generations to come.
So when the US government decided to spend billions of dollars to rebuild its semiconductor industry, everyone was watching, right? We all wanted to see where that first chunk of cash would go. Would it be some huge, flashy new factory for the latest consumer tech? Well, the CHIPS Act's first move was not that. It was something way more strategic, and it revealed the real priority behind this whole massive investment: national security.
And the very first award wasn't for billions. Nope. It was a much more focused, much more targeted $35.5 million.
And when this grant dropped in December 2023, it sent a really clear message. This wasn't just a grant, it was the first one. A deliberate statement of intent about what this whole industrial policy was really trying to do.
Which of course brings up the big question. With all the public attention on consumer electronics and global chip shortages, why on earth did this landmark first grant go to a defense contractor? Well, the recipient, BAE Systems, tells you everything you need to know. This immediately signals that national security is the CHIPS Act's #1 job. This funding isn't for a factory that sells chips to just anyone. It's for what they call a captive facility, which basically means it builds specialized chips exclusively for BAE's own advanced weapons systems.
So the money is going to a very specific place, the Microelectronics Center in Nashua, New Hampshire. Now, this isn't just some warehouse. We're talking about a 110,000 square foot cathedral of defense tech. It's an officially DoD-accredited trusted foundry, and its history goes all the way back to the 1950s.
And what they make here is not the kind of silicon you'd find in your phone or your computer.
The Nashua facility specializes in something called monolithic microwave integrated circuits, or MX for short. Put simply, these are highly specialized chips designed to play with the electromagnetic spectrum, that invisible world of radio waves and microwaves all around it. And to do that, you need a completely different kind of raw material. This gets right to the heart of why this technology is so incredibly critical for national defense. Think of it like this. On one side, you have silicon. It's the workhorse of computing, right? It's great for processing information. But on the other side, you have gallium nitride, or GaN. GaN is the absolute champion of power and frequency. Electrons move through it way faster, and it can handle a whole lot more voltage and heat. It's just tougher. And this isn't just some minor engineering detail. For a fighter pilot, it can literally be the difference between life and death. A radar system built with GaN can see much farther, and a GaN-based jammer can blind an enemy from a safer distance.
So where does this life-or-death technology actually go? Well, let's connect it to one of the most advanced military platforms anywhere in the world.
The crown jewel application for these chips coming out of Nashua is the electronic warfare suite for the F-35 Lightning II fighter jet. See, an F-35 stealth isn't just about its shape, it's about its ability to control its electronic signature, and these chips are the brains behind that entire magic trick.
So how's it work? Well, the system gives the pilot this incredible 360-degree awareness. First, it's just passively listening for any enemy radar. If it detects a threat, let's say a Russian S-400 missile battery, it then identifies exactly where it is and what frequency it's using. Finally, it reacts, either by jamming that signal completely or deploying decoys to confuse it. And this is what that $35.5 million grant directly pays for. It's going to quadruple the production of these critical chips. It's going to replace old, aging factory tools. And get this, it cuts the F-35's modernization timeline in half, all to stay ahead of new threats coming from adversaries like China and Russia. But here's the thing, a high-tech factory is completely useless without the people to actually run it. And this is where the story takes a really fascinating turn, revealing a problem that's very human-sized.
BAE Systems was facing what they call a demographic cliff. Basically, the expert technicians who had run this specialized facility for decades, they were all getting close to retirement. And you can't just post a job on Indeed to find someone to do this kind of highly skilled work.
So, as a condition of getting that CHIS funding, BAE partnered with Nashua Community College to come up with a brilliant solution, a 10-week microelectronics boot camp. The whole goal? To take people with zero semiconductor experience and turn them into certified operators skilled in super specialized things like wire bonding and die attach. And how did it go? Well, the program has been a staggering success, achieving a 97% hiring rate. It's creating a brand new pipeline of talent for this absolutely critical defense facility. But this part, this is where the story becomes truly profound. We learned that at least 75 graduates of this program identified as homeless before they enrolled. Just think about that. This wasn't just a workforce program. It was a pathway to a stable, high-paying career for people who needed it the most. Okay, so let's zoom out for a second and connect all these dots. This single, relatively small grant reveals a much bigger, much more holistic strategy at play.
When you really break it all down, this one grant delivers 3 huge policy wins at the same time. For national security, you're countering peer adversaries. For industrial policy, you're quadrupling domestic production of a vital component. And for social policy, you're creating a tangible pathway out of homelessness and into the middle class.
All right, today we're going to unpack the story of Skywater Technology. And, it's really a fascinating tale of 2 very different chip fabs. One's a quiet success story, and the other, well, it's more of a cautionary tale. In this high-stakes race to rebuild America's tech industry and bring manufacturing back home,
Well, it turns out one company's story reveals pretty much everything about what works and, maybe more importantly, what doesn't.
So, to really get this story, we've got to start with a kind of fundamental question. What if a chip's real secret isn't the design itself, but how it's made? I'm talking about the unique, sometimes even exotic process of actually building the thing. And that question brings us right to Skywater Technology. They're based out in Bloomington, Minnesota, and they have this really unique position. Get this, they're the only US-owned and operated pure-play foundry. And pure-play just means their whole business is making chips that other companies design. That's it. Okay, so here's where Skywater just flips the standard foundry model completely on its head. You see, the traditional giants, think TSMC, they're all about huge volume. A customer sends them a design file, and they just crank out millions of identical chips. But Skywater, they do the exact opposite with their technology as a service model, or TAS. They literally invite their customers into the lab with them to co-develop the manufacturing process. The customer isn't just a customer, they're a partner.
So you might be asking, who on earth needs a model like this? Well, it's absolutely crucial for anyone where the secret sauce is the manufacturing process itself. We're talking about defense contractors who might be using really exotic materials, or those deep tech startups playing in areas like quantum computing and photonics. For them, the chip itself is a breakthrough in physics, not just a slick design.
And that super unique model, it leads us right into our first story, the expansion of their facility in Minnesota. And this turned out to be a textbook example of a strategic, a sure bet.
So let's look at how the public money here created private growth. It's actually a pretty cool chain reaction. It all started with a relatively modest $16 million grant from the Federal CHIPS Act. That then unlocked another $19 million from the state of Minnesota. And with that government seal of approval, bam, Skywater was able to go out and attract a ton of private capital, leading to a total investment of over $350 million. It's just a perfect example of how a little bit of targeted public seed money can leverage massive private sector growth.
But hold on a second. You might be looking at this and thinking, why invest all this money in 90-nanometer technology? I mean, that sounds kind of old, right? Especially when the cutting-edge stuff is down in the single digits. Well, it's because for these mission-critical applications, the newest thing isn't always the best thing. We're not just talking about business here. This is about national security. This funding directly supports making what are called readout integrated circuits, or ROICs. These are basically the brains inside the thermal imaging and night vision for the US Army. It also helps secure the domestic supply of rad-hard chips. These things are specifically designed to survive the super harsh radiation environment of space, and they're absolutely non-negotiable for the US Space Force and our nuclear systems.
Okay, so that was the success story. But for every sure bet, there's a gamble, right? And that brings us to our second story. The very ambitious, but ultimately doomed plan for a brand new factory out in Indiana.
So check out this timeline. Back in July 2022, there was huge excitement. Skywater announces this massive $1.8 billion facility with Purdue University, an absolute powerhouse for engineering talent. But then, the federal funding priorities started to shift, and by early 2024, the project was officially shelved. Just like that. A really short, but very hopeful life.
So, what happened? What went wrong? Honestly, it just comes down to a mismatch of scale. I mean, look at the numbers. Skywater's entire revenue for 2023 was about $286 million. The Indiana project was going to cost 1.8 times billion dollars. The math just doesn't work. Not with a massive grant from the CHIPS Act. And this is really the heart of it. The federal funds just weren't there in the quantity needed to make that kind of risk acceptable. The Department of Commerce, they made a strategic choice. They decided their priority was modernizing existing fabs, like the one in Minnesota, and funding a few giant leading-edge projects with the big players. So for a mid-sized company trying to build a whole new factory from scratch, the money just wasn't going to be there. But wait, the story doesn't just end there with a failed project. Because the collapse of the Indiana plan actually reveals some really fascinating lessons for America's whole tech future.
See, just as that Skywater deal was falling apart, something incredible happened at that exact same research park at Purdue. The South Korean giant SK Hynix swept in with a huge plan of their own.
So remember that number, right? 1.8 billion. That was the Skywater plan, the ambitious plan that failed.
Now get ready for this. The SK Hynix investment that succeeded in the very same spot is more than double that. We're talking $3.87 billion. Wow. So what's the big takeaway here? It's that these strategic tech hubs, the ones anchored by amazing universities like Purdue, are incredibly resilient. Even when one specific company's plan falls through, the hub itself, that ecosystem of talent and research, remains this powerful magnet for investment. The place itself is the prize. For the last 50 years, one simple rule has basically powered our entire technological revolution. But that rule is breaking down. So what on earth comes next? Well, it turns out the future of AI isn't about getting smaller anymore. It's about building skyscrapers.
And this is really the central question facing the entire tech industry, isn't it? Because when a rule that's defined progress for half a century just stops working, it's not just an ending,
It's the beginning of something totally new, and honestly, something potentially way more powerful.
So, to really get a handle on where we're going, we first have to talk about the rule we're leaving behind, the legendary Moore's Law.
I mean, this was just this beautiful, simple engine of progress. For decades, the goal was singular: shrink the transistor, cram more of them onto a chip. And this one little observation meant our devices got exponentially faster and cheaper year after year. It's the reason the phone in your pocket is more powerful than a supercomputer from not that long ago.
But we've hit a wall, a hard wall. That steady, predictable climb has run into some harsh physical and economic realities. We're now in what they call the angstrom era. We're trying to build things on an atomic scale. And at this level, shrinking things down even further is becoming outrageously expensive, and you're just not getting the same bang for your buck. The old playbook, it's finished.
So, if you can't build smaller, what do you do?
Well, the industry's answer is actually brilliant. You don't build smaller, you build smarter. You build up.
And this is the best way to think about it. It's a total shift in philosophy. Instead of trying to cram more and more little single-story houses onto a flat piece of land, engineers are now just building skyscrapers.
We're talking about a literal move from a 2D world to a 3D one. By stacking chips directly on top of each other, you can create these incredibly dense, powerful systems without having to shrink a single transistor any further. This whole revolutionary approach is called advanced packaging.
And sitting right at the heart of this vertical revolution is a technology that is absolutely 100% essential for the future of artificial intelligence. It's called high bandwidth memory, or HBM.
So unlike the memory that lays flat in most computers, HBM is, well, it's a skyscraper of memory chips. You've got these individual layers of memory called dies stacked vertically, and they're connected by these microscopic tunnels that go right through the silicon itself, creating this ultra-fast, direct superhighway for data to travel.
And when I say superhighway, I am not kidding. The next generation of these HBM chips can move 1.18 terabytes of data per second. Just let that number sink in for a moment. Okay, to put that in perspective for you, that's like downloading 230 full-length, high-def movies in the time it takes you to snap your fingers. That is an almost unbelievable amount of data throughput.
So that begs the obvious question, right? What on earth needs that kind of insane speed? The answer is simple: AI.
See, training a large AI model involves trillions upon trillions of calculations. And the powerful processors doing that work, the GPUs, they're incredibly hungry for data. If the memory can't feed them information fast enough, the processor just sits there, idle, wasting time and energy. It's a bottleneck, and it's called the memory wall. HBM is what smashes right through that wall, giving AI the massive, high-speed flow of data it absolutely craves.
And here's the thing. This isn't just a theory on a whiteboard somewhere. This vertical metropolis is actually being built right now. And it's happening in a place you might not expect, the American Midwest. A South Korean company called SK Hynix is making a massive bet on Indiana.
And when I say massive, I mean it. We're talking nearly $4 billion. That's the scale of the investment they're making to build one of these cutting-edge facilities on US soil.
So this new facility, it's going to be located at Purdue University's Research Park, and it is specifically designed to produce the HBM chips that are literally the lifeblood of AI. It's a complete hub for everything: advanced packaging, fabrication, and research and development.
But you have to understand, this is about so much more than just one factory. Its construction is going to have these huge ripple effects, not just for the local community, but for the entire global technology landscape.
I mean, just look at the impact. Geopolitically, it's a huge deal. This brings a critical piece of the AI supply chain right here onto US soil for the first time, making everything more resilient. Technologically, it anchors a new R&D hub. And for the economy, we're talking about 1,000 high-paying jobs, plus it builds this direct talent pipeline with local universities to keep that innovation going for years.
And this is what's really key. SK Hynix isn't just building a factory in a field. They're building an entire ecosystem. They're tying in directly with Purdue for deep research, they're creating new school programs with local colleges, and they're even setting these ambitious environmental goals like being carbon-free. It's a really holistic vision.
Okay, think of it like a high-stakes relay race with 3 stages. First, a company like NVIDIA designs the chip. That's stage 1. For stage 2, they pass the baton to a foundry like TSMC to actually make the wafer. Then, for the final, crucial lap, the baton is handed off to a company like Amkor. They're the ones who handle the packaging and testing that turns that raw silicon into a finished product that actually works. So what are these companies called? Well, the industry term is OSAT. That stands for Outsourced Semiconductor Assembly and Test. Their entire job is to take those wafers, carefully slice them up into individual chips, put them in protective packaging with all the right connections, and then test them like crazy to make sure they work perfectly. Without an OSAT, those wafers from the world's best foundries are basically just really, really expensive paperweights. And that brings us to Amkor Technology. They are one of the world's biggest and most important OSATs. And right now, they're making a massive $2 billion bet on building a critical piece of the semiconductor supply chain right here in America. So what in the world is going on inside this new $2 billion facility? Well, at the heart of it all is a revolutionary technology that is absolutely essential for things like AI and supercomputing. It's called 2.5D packaging. So traditionally, you might stack chips vertically, but with 2.5D packaging, you place them side by side. You have your main processor, say a GPU, sitting right next to your high-speed memory. And they both sit on this special base called a silicon interposer. You can think of this interposer as a super fast, high-density bridge with thousands of connections running between the two chips. It completely solves a major data bottleneck. And what's the result of all this? Incredibly fast, low-latency communication. Because the data just doesn't have to travel as far, it moves quicker and uses less power. For huge AI models or massive data centers where every single nanosecond and every watt of power counts, this kind of efficiency, it isn't just a nice to have. It's a total game changer. But this amazing packaging tech is just one piece of a much, much bigger story. See, Amkor isn't just building a factory. They are laying down a vital cornerstone for a brand new American semiconductor hub out in Arizona. And its strategic importance for the whole country, well, it's massive. Let's just talk about the scale here for a second. Amkor is putting $2 billion into this. This isn't some small experiment. This is a gigantic commitment to bringing this critical final stage of chip manufacturing back home to the US. And they're not doing it alone. This project is being backed by the US government's CHIPS Act, with up to $400 million in potential funding. This is a huge piece of a national strategy to make our domestic supply chain more secure and less reliant on manufacturing overseas. And the location? It's absolutely genius. Amkor is building this facility right next door to TSMC's new factories. This means they can do a direct wafer-level handoff, moving those delicate wafers straight from the foundry to the packaging facility. It slashes shipping times, cuts costs, and dramatically reduces the risk of damage. It's creating this powerful, self-contained tech hub right in the middle of the Arizona desert. But look, this story isn't just about silicon and supply chains, it's really about people. Because this kind of high-tech investment creates a very specific and very powerful kind of opportunity that can completely transform a community. This one facility is on track to create 2,000 new high-tech jobs in Peoria, Arizona. But what's really amazing isn't just the number of jobs, it's the kind of jobs we're talking about. Just think about this for a second. To be a chip designer at a company like NVIDIA, you almost certainly need a master's degree or even a PhD. But for many of these critical advanced packaging and testing jobs at Amkor, they're accessible to technicians who have certifications from a local community college. And that's the real impact here. This creates a direct path to a high-paying, stable career in tech without that massive hurdle of a 4-year degree. This is about building a strong, skilled middle class, one perfectly packaged chip at a time. Okay, so when you think about the future of AI, what comes to mind? Probably silicon, right? Software, complex algorithms. But what if I told you the key to the next big leap in AI isn't some brand new sci-fi invention, but something ancient, simple, and literally all around us? Yeah, I know, it sounds kind of crazy. Fragile glass powering the most advanced tech we've ever built. But believe it or not, this isn't science fiction. It's a real breakthrough happening as we speak. And to really get why this is such a huge deal, we first need to talk about one of the unsung heroes of computing. It's called the substrate. And you can basically think of it like the foundation of a skyscraper. The skyscraper is the super powerful chip, and the substrate is what connects it to everything else, letting it talk to the rest of the computer. The problem is, for decades, that foundation has been quietly, cracking under the pressure. And that cracking foundation, it's created this massive bottleneck for AI. We're designing these incredible, powerful new AI models, but the very platform they're built on just can't keep up anymore. It's like trying to run a supercar on bicycle wheels. See, for years and years, that substrate was made from a simple plastic-based material. It worked fine, it was cheap, it got the job done for the computers of the 80s, 90s, and 2000s. But modern AI, yeah, it's a whole different ballgame. And this is where the problem really hits. You've got these modern AI chips that are just unbelievably powerful. They're like tiny little suns generating a ton of heat. But they're sitting on these old-school plastic substrates that literally warp and buckle when they get too hot. They have hit a wall, a hard physical limit, and it's holding everything back. So it's pretty obvious, right? We need a new foundation, something much stronger. And that brings us to the solution, a revolutionary new idea. And it's, well, crystal clear. So where is this solution coming from? You might be surprised. It's happening in Covington, Georgia, at a company called Absolics. They're the ones pioneering this breakthrough. They're ditching the plastic entirely and betting the future of AI on glass. And you really can't overstate how big of a shift this is. I mean, this isn't just a small tweak or a minor upgrade. A great way to think about it is like the shift from those giant, hot, glowing vacuum tubes to tiny little transistors. That's the scale of change we're talking about here. It's a fundamental leap forward that is going to completely redefine the next era of computing. Okay, so why glass? I mean, of all things, why glass? What makes this everyday material the secret ingredient? Let's break down exactly why it works so well. It really comes down to a few key properties. You could almost call them superpowers. First, glass is incredibly flat and super stiff. Second, it's thermally stable, meaning it doesn't warp or bend when things get hot. And third, its electrical properties are just way, way better. Each one of these on its own is a huge deal. And here's where it all comes together. Because the glass surface is so perfectly flat and stable, engineers can etch circuits onto it that are unbelievably fine and packed super close together. What does that do? It lets them create way more data channels. Think of it like turning a tiny country lane into a massive multi-lane superhighway for data. It just lets information fly between chips at speeds we couldn't get before. But wait, there's another huge win here. Get this. Because glass is a better electrical insulator, less energy gets lost as wasted heat. Now, this doesn't just make things faster, it dramatically cuts down on power consumption. And that is a massive problem for the giant power-hungry data centers that run all the AI we use today. So this isn't just some theory in a lab, right? This is happening now. This technology is being built at a huge scale, and it's turning a part of Georgia into the absolute epicenter of this new glass revolution. And it's not going unnoticed. This is so important, it's being recognized at the highest levels. The US government is looking at this and saying this is critical for the future of computing, and they're investing a lot of money to make sure this revolution happens right here in the US. Just how much money are we talking? Up to $75 million. That's direct funding from the CHIPS Act. When you see a number like that, it's a clear signal that this isn't just a cool new tech, it's become a strategic national priority. And that money is going somewhere very real. It's helping to build a massive 120,000 square foot factory, a huge state-of-the-art facility with one single purpose: to mass produce these glass foundations for the next generation of AI. You know, this is actually a fantastic example of how innovation is supposed to work. The whole idea started out in the research labs at Georgia Tech. From there, it was handed off to the company Absolics to figure out how to actually make it in the real world. That's the perfect pipeline, from the lab straight to the factory floor. And the impact here goes way beyond just the technology itself. We're talking about real-world effects on the community. This one project alone is expected to create or support more than 1,200 jobs. That's everything from the construction workers building the place to the high-tech engineers and technicians who will actually run it. And what's really cool is that Absolics isn't just dropping a factory in and calling it a day. They're actually investing in the local community. They're putting over $100,000 a year into local technical colleges. Why? To train the people right there in the community to do these highly skilled, high-tech jobs.
And this quote, well, it just nails it. We're talking about a complete, conscious rethinking of a supply chain that, as we've all seen recently, is incredibly fragile. The new goal is simple, but it's a game changer: resilience.
So, okay, if you're going to do this grand redesign, what are the actual blueprints? What does it really take to build an entire secure semiconductor ecosystem basically from scratch? Let's get into it.
First things first, we have to understand the ultimate goal here. And this goes way beyond just economics. This is really about national security. The whole idea is to build what's being called a silicon shield, a defense posture that's built on the strength and resilience of American manufacturing.
So the strategy is to create a fully integrated network right here at home. Every single piece of the puzzle, from the rawest of materials all the way to the final, incredibly complex AI systems, needs to be secure on American soil. This is a direct response to those fragmented and frankly vulnerable global supply chains we've been relying on for decades. Now, before you can even think about building those massive, high-profile chip factories, you need a vast, almost invisible foundation. This is the network of suppliers providing the essential picks and shovels that make the entire digital gold rush even possible.
And it all starts with something you can find on almost any beach: sand. Seriously. The journey of every single microchip begins right here, and a Michigan-based company called Hemlock Semiconductor is responsible for that first absolutely critical transformation.
This first step is just incredible. They take ordinary sand, or silica, and turn it into something called hyper-pure polysilicon. You can think of it as the refined, ultra-pure crystal foundation that every single microchip is built on.
And when we say pure, the level it's just hard to wrap your head around. We're talking 11 nines of purity, 99.9999999%. A single stray atom isn't measured in parts per million or billion, but in parts per trillion. Without that level of perfection, modern electronics just plain wouldn't exist. Okay, so on to the next challenge. That super pure polysilicon gets turned into these thin, perfect discs called wafers. Inside a factory, a fab, these wafers travel for miles on automated tracks. Here's the problem though. A single microscopic speck of dust can wipe out hundreds of chips on one of those wafers. So how in the world do you keep them perfectly clean? The solution is this thing, the Front Opening Unified Pod, or FUP for short. Now, it might look like a simple plastic box, but it's actually a hermetically sealed microenvironment. It's its own personal portable clean room. A company called Entegris is actually building a brand new $600 million facility in Colorado just to make these, ensuring US factories have a secure supply. But Entegris' job doesn't stop there. Modern chip making uses hundreds of specialized, often toxic chemicals that have to be perfectly pure too. And this quote, it just captures their other critical role perfectly. Their filtration systems are basically the kidneys of the fab, constantly purifying all those essential fluids.
Now let's look at another critical piece of this foundation. You can't make chips in the open air, right? The whole process has to happen in a vacuum. But until very recently, the special pumps you need for this were a glaring gap in the US supply chain. That's now being filled by Edwards Vacuum, which is building a new $319 million facility in New York.
And you might think a pump is a pump, right? Well, not in this case. You can't just use any old industrial pump. Standard pumps use oil, which would instantly contaminate a pristine clean room. Chip making needs these specialized dry pumps that are completely oil-free and tough enough to handle all the corrosive gases used in the process. So let's just recap this foundational layer for a second. You've got Hemlock providing the raw material, you have Entegris making sure everything is transported safely and the chemicals are pure, and you have Edwards creating the vacuum needed to do the work. All of these picks and shovels have to be in place before you can even try to make a single advanced chip.
All right, so with that foundation being built, we can move up the pyramid to the next big challenge, securing the future of chip innovation itself. And believe me, that's getting exponentially more difficult and expensive every single year.
So here's the new reality of the situation. As we try to push the laws of physics to make chips smaller and more powerful, the R&D cost has just skyrocketed. No single company, not even the giants, can afford to do it all by themselves anymore. The only real way forward is to collaborate.
And to solve for that, Applied Materials, the world's biggest equipment maker, is betting $4 billion on a new R&D hub out in California. The whole goal is to create a central R&D brain trust for the entire American semiconductor industry.
And the purpose of this center is to be, and I love this quote, the Switzerland of the semiconductor industry. It's designed to be a completely neutral ground where the fiercest rivals can come together and work on those fundamental physics problems that are just too big for any one of them to solve alone.
And yeah, we're talking about the biggest players in the world, Intel, TSMC, and Samsung, all working in the same facility. This new hub lets them test new equipment and design new chips at the same time. It's a model called concurrent engineering, and it could literally shave years off development cycles.
So let's zoom back out for a minute. How do all these foundational pieces and these new innovation hubs, how do they all come together to form that complete architectural redesign we were talking about at the start?
This right here is the full picture of that new ecosystem. See how it works? It starts with securing raw materials, like with Hemlock. Then it builds a robust infrastructure with companies like Entegris and Edwards. And then it accelerates future innovation with collaborative hubs like the one from Applied Materials. Each layer builds on the last, creating a secure pipeline for the AI systems of the future.
And you know, it all comes back to the ultimate goal, which this quote just captures perfectly. The aim is a defense posture that is built not just on clever designs, but on the tangible, resilient foundation of American manufacturing.
At the end of the day, what we're really watching is a fundamental pivot. It's a deliberate move away from a fragile, globalized system and toward a robust, integrated domestic network, one that's actually designed for long-term stability and leadership.
So the blueprint is clear and billions of dollars are being invested. But there are still huge challenges ahead, from construction delays to finding tens of thousands of skilled workers. And that leaves us with the critical question. The foundation for America's silicon shield is being laid, but in a global race for technological supremacy, can it be built fast enough?